Yeah, welcome to YouTube, Easy Learning YouTube. And this is what I have for you today. The question on X-ray, which said an X-ray tube is operating at 150 kV. What is the shortest wavelength that can be emitted by the sudden stopping of an electron when it strikes a target? So this is a question on X-ray. Our last lesson we deal with X-ray production and everything pertaining it. Right now we are doing the word calculation on it. So for us to go to this, let's just go straight to what we have. Solution of this question. We remember that energy, which we call kinetic energy, is 1/2 mv squared, and is equals to EV, which is electron volts, and is equals to Hc, and is equals to Hv, and is equals to Hc over what? Lambda. You remember, this man is a velocity. This man is velocity. Why this man is voltage? This, so that you will not confuse yourself with this and this. This man is velocity. This man is voltage. And this man is what? Charge of electron. That's electron charge. Electron charge. This is electron charge. Then this man is the mass. Either the mass of electron, if it's electron moving, or mass of the substance that is moving, mass of the substance or object, substance that is what moving. Why this man is what we call Planck constant. Call it Planck constant. And this man is called frequency. And this man is called speed of light. This man is wavelength. Is a wavelength. Then somebody will ask, how did I get this? You remember that we said speed of light is equals to frequency times lambda. And making the frequency subject of formula, I have C over lambda. Then substituting this, taking this to substitute for frequency, I have this. I will have what? This. So what does this equation mean? This equation simply means that I can equate these two, it become my equation. I can equate these two, it become my equation. I can equate these two, it become my equation. I can equate this to this, it become my equation. I can equate this to this, it become my equation. Then whatever I'm going to equate is categorized by the equation given to me, the parameter given to me. If the parameter said mass, I'm going to use this. But if the parameter said frequency, I'm going to use the one that involves frequency. Right now, let us go back to the equation. It said an X-ray is operating at 150 kV, meaning voltage is given to me. That means this man have to be there. Then they now said I should what? Calculate the shortest wavelength. Where did I see wavelength in this equation? Look at it. That means I can now equate this V over EV equals to what? Hc over lambda. Then what they say I should get? They say I should get what? The lambda. I will not make the lambda subject of formula. I will say that I will not say EV over 1 is equals to Hc over lambda. Making lambda subject of formula, I will have EV times lambda is equals to 1 times Hc. Then I will have that lambda is equals to Hc over EV. Hc over EV. Where H is a Planck constant, which is 6.6 times 10 raised to power minus 34 joule seconds. And again, C is equals to 3.0 times 10 raised to power 8 meter per seconds, comma, that's speed of light. Then E is equals to charge of electron. Electron what? Electron charge. Electron what? Charge. And what is electron charge? Is equals to 1.6 times 10 raised to power minus 19 coulomb. That's electron charge. Then V, which they give me, V is equals to voltage, which is 150 kilovolts. Why this K stands for 1000, which we call kilo, which gives me 150 times 1000 V, give me times 1000 V, which gives me 150,000 V, which is voltage. Then substituting this value, I'll have this equals to what we have here, HC all over EV. Then what they asked me is shortest wavelength. If you remember, when we talk about, we say that C is equals to F lambda. If I make the lambda subject of formula, if I make V subject of formula, I will have F maximum. F maximum is equals to C over lambda minimum. What does it mean? Somebody will say, what does that mean? For me to get this man maximum, this man must be what? Minimum. For F frequency to be maximum, the lambda must be what? Minimum. Let's look at example. For instance, if C is 4, if the value of C is 4, and I have the value of lambda to be 2, what am I going to have? 2. Then what of if I have C 4 and the lambda to be 3, what will happen? It will have 1.3 something something. That means that what? The more the lambda, the lesser the what? The frequency. So the lesser the lambda, the more the frequency. So for me to get the maximum frequency, I must have a minimum wavelength. For me to get maximum frequency, I must have what? Minimum wavelength. So when I see that this is what we call minimum wavelength, this means minimum wavelength. Minimum wavelength, which we'll call shortest, minimum wavelength. Minimum wavelength, which we'll call also, we call it what? Shortest wavelength, which we call shortest wavelength as well. We'll call it shortest wavelength. This minimum wavelength is also called shortest wavelength. Then coming here, I will have this to be minimum, which is equals to HC over EV. Substituting the value, I'll have minimum, which is equals to 6.6 times 10 raised to power minus 34 times 3 times 10 raised to power 8 all over. This becomes 1.6 times 10 raised to power minus 19 times 150,000. Yeah. You cannot bring out your calculator. This is shortest wavelength. Can bring out your calculator. Then when you bring out your calculator, open the bracket this way. When you open bracket, have you open bracket in your calculator with this? You will see this in your calculator. Just press it down when you open bracket. Then type 6.6. Have you typed 6.6? This place you press what? Shift. When you get here, press shift, press log. When you press log, you see small 10 there. You press minus 34. Have you pressed minus 34? Then press times again. Press 3. Here, when you get here, press shift. Have you pressed shift here? Press log. Then 8. Close the bracket. Have you closed the bracket? Then you press divide. Have you pressed divide? You open bracket again. You press 1.6 shift. When you get here, press shift, log, you press -1,9 times 150,000. When you press it, you close, then you press equals to. What you are going to see, you are going to see 8.25 times 10 raised to power minus 12 meter. That's what you are going to see there. Then when you have seen that, that's our answer. You cannot say that what this man can be written as 0.0825 times 10 raised to power minus 10. Do you agree with me? I can write this way. This answer, I can write it this way. What does it mean? If I want to change this man to what standard form, 825, I can say it's what 8.25 times 10 raised to power minus 2, right? That means 10 raised to power minus 2 times 10 raised to power minus 10. Look at me here. That will give me 10 raised to power minus 12. I think I've come back to what I had before. So what I'm trying to do here, this man here can be written as 0.0825 Armstrong units. This become my what answer, and this is answer. This man is what we call Armstrong unit. This man is equals to 10 raised to power minus 10 meter. And this is called what? Armstrong. And what? Strong. Armstrong units. Armstrong units. That's what you call. It's called Armstrong units. So he said, shortest wavelength is equals to this is an answer. I think you know. This is a correct answer. But I'm trying to use this opportunity to teach you what is called what? Armstrong unit. So that when you see this man, 1 Armstrong unit is equals to 10 raised to power minus 10 meter. So I'm trying to put the Armstrong unit here. I have to what? Make this to be raised to power what? 10. By removing -2 from this man, I will have 0.08. That stands for what? 0.08 stands for what? -2. And I'm reduce this. You get what I'm saying? And that's what I did here. So when you have done this, you have Armstrong. Now notice that 1 Armstrong is 10 raised to power minus 10 meter. Is meter. Then again, coming to this place again, sometimes your calculator may not be able to handle the heavy power here. You can as well use your what? Indices. This man here, I can write it as what? 6. I can write it as 6.6 times, again 3, times 10 raised to power minus 34 times 10 raised to power 8. Are you get what I'm saying? Huh? This man here, I can write it this way. And these are cancelling themselves, and they are of the same base, and I'm using this law. I can now add their power by saying minus 34 plus 8. That gives me minus 26. I can now write this 6.6 times 3 times 10 raised to power minus 26. This thing here, I can write it this way, using what? Indices. Likewise, the down one, the denominator, I can make this in the standard form and we have to reduce the what? The power and divide. We're going to see it in subsequent question. Then, this is what I have for you today. If you love what we are doing in this channel, subscribe, share to your friend, inform them, comment. If there is any comment you have, comment, because your comment will help us to what? Adjust in the area that you don't what? Understand. Thank you for loving this video. Thank you for subscribing. See you the next class.